Software Engineering Radio, episode 129, F# with Luke Hoban.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for support. Welcome to another episode of the Oopsla podcast. This is Marcus on the phones here or on the mic, and today we're talking to Luke Hoban from Microsoft, and he's the F# program manager. Hi, Luke.
Hi.
So please introduce yourself briefly to our listeners.
Sure thing. So my name is Luke Hoban. I'm the program manager on F# at Microsoft. And F# has been a research project in Microsoft for the last 4 or 5 years. And just recently, last year, we decided to turn it into a sort of supported Microsoft product. And so I'm working in the group in Microsoft that's working on taking F# from a research project and making it supported part of the programming languages on .NET.
Many people might have heard about F# already, and the sharp makes it a typical .NET language, I guess. But can you maybe give our listeners a brief introduction of what F# is, like, F# in a sentence or something?
Sure. So F# in a sentence, F# is a functional programming language for the .NET platform. So it's a functional language, just like many others, Scheme, Lisp, Haskell, ML. And it most directly inherits from the ML family of languages, and specifically shares a core language with OCaml. But it's a language that's really fully integrated into .NET, and so it takes .NET's strong OO system and bakes that very strongly into the F# language itself, and also has good tools for doing imperative programming and for doing sort of explorative programming in specific domains.
And I guess we'll look at some of those, let's say, buzzwords or core concepts in more detail as part of the interview. So if you say it's a functional language, then, we've had episodes on functional languages before, so people probably know that functions are a core, aspect of functional languages. So can you maybe elaborate a little bit on how functions are used and how their use is different from what we know as functions in, Pascal or C?
Sure. Yeah. So, in the end of the day, functions are, in Pascal or C are sort of very similar ideas. But in a functional language, we tend to take that a step further and allow functions to be used as first-class values, and so they can be passed around. They can be assigned to variables. They can be put inside data structures, and they can be passed as arguments to other functions. And this ability to pass around functions as arguments to other functions allows you to write allows you to abstract out pieces of code in a lot of ways that weren't previously possible with just standard procedural programming techniques. Right. And so functional languages tend to really emphasize the use of that technique.
So that's also one other of your points is the succinctness of being able to express algorithms in a very brief, succinct fashion. I guess the functional aspect of functions are a big part of that.
Yeah, I think the ability to pull out the common pieces of your code and abstract those using things like first-class functions, and the fact that these languages tend to be immutable, so it's easier to pull out pieces of code, makes it so that we can ultimately write the core of your code in a very, very succinct way that captures the sort of domain that you're working in. And so I think that's really one of the things that you see that's a striking difference between typical code written in a functional language as opposed to a procedural or imperative style.
You already mentioned the word immutable. Can you, explain why this is important in functional languages? I guess people know what it means. You can't change a data structure. You can't mute it, migrate it, change it once it's defined through a constructor or something. But why is that important for functional languages?
Sure. So, it's important for functional languages for a number of different reasons. The basic idea is that you obviously, as you said, you can't, once you sort of assign some data to a variable, you can't change what that variable means later on.
Right.
And that's beneficial for this idea of being able to pull out pieces of code and reuse them If you can change the values of things, then you can end up with shared state, where different parts of your system all know about the same state, and if they change it, that can affect the behavior of some other remote component. And object-oriented techniques try to use encapsulation and things like that to hide away that state and control access to it. But when you have an immutable system, it means that you don't have to worry about other people trying to change your behavior. You really are entirely in control of it. But I think that becomes really interesting just beyond the basics of the software engineering things. It becomes interesting with the move towards parallel and distributed computing being more and more common.
Right.
And the fact that with the many-core era that's about to begin, we really, parallelism and massive scale parallelism is going to have to be a part of how development is done. And when you're doing parallelism, really one of the big problems that you run into, one of the big things that causes that to be a very hard problem to solve typically, is whenever you have shared state, if the different threads that are running, if the different pieces that are trying to run independently are all trying to talk to that same shared state, you're just bound to run into problems. And it's really the place where lots and lots of techniques have been come up with to try to address that. But ultimately, the best way to address it is just to avoid having that shared state. And functional languages with immutability tend to provide a toolbox of techniques for programming without shared state.
At least without shared mutable state, because that's
right,
the problem. Yeah. So is that one of the reasons, or the main reason, why F# has made it into a product? Is because multicore is becoming more important and functional languages are useful in that respect?
I think that's one of the big reasons. Clearly, there's an acknowledgement that the functional programming techniques, whether it's F# or some other language that even on the .NET platform, we've seen C# and Visual Basic both pick up a few functional programming techniques versions. But I think there's a recognition that those techniques are going to be an important ingredient in the sort of many-core programming era. But I think for F#, yes, that's one of the big things. It's a language that's built from the ground up as a functional language that has the full tool set to really allow you to write programs that are, by and large, immutable, but have access to the broader .NET platform. But I think beyond that, there's other reasons as well why F# has been sort of moved more into the mainstream of .NET. Which is that it really is the explorative idea and the appeal to sort of technical and algorithmic developers is something that the .NET platform hadn't had any strong language for in the past. And so F# is really trying to sort of broaden the platform out a bit towards some of these developers who are doing very technical work or algorithmic work or working in an environment where they're trying to just explore in an interactive style.
Yeah, I'll come back to this explorative style in a moment, but I want to briefly revisit this immutability stuff because there is also a keyword called mutable that allows data structures to be marked as mutable because the default is immutable. So it's not a pure functional language. Is the reason why you introduced this mutable keyword the compatibility with existing .NET frameworks, or because you could argue that if you do functional, you should do pure functional, right?
Yeah, so there's often a debate. I think there's been a long-standing debate in the functional languages community about about purity and about how far you can go and what you should lose by not going all the way towards purity and saying that you really can't have any shared mutable state. Yep. F# is not a pure functional language. And so it does allow you to do imperative programming. It does allow you to have shared mutable state. And really the main reason, as you said, is the .NET platform. Okay. To be able to access all of the rich frameworks that are available there, which are really, they really are critical to a language being, these days, the APIs that you use are really a large part of your programming experience. Right. And they're where a language really gains a lot of its usefulness through the set of libraries it has access to. Yep. So the .NET platform clearly does have lots of shared mutable state. Clearly, when you create an array on .NET, you can modify values in the array. And these techniques are useful programming techniques. F# layers on top of that the ability to do immutable functional programming on top of that.
And another thing that I found interesting about F# is the fact that it's strongly typed. That's not necessarily typical for functional languages, although of course there are others with very sophisticated, strongly typed type systems. Is the reason again the fact that it needs to run efficiently on the CLR, or is there a more conceptual reason for having it strongly typed?
Well, I mean, F# is initially inherited from the OCaml languages, and so the ML family of languages, which all sort of were strongly statically typed, but used type inference to be able to give a sort of sweet and succinct syntax in the language. And so F# really inherited a lot of the, it's sort of those ideas from the ML family of languages and from the success that they've had. I think there's also the idea that, if you are statically typed, you can compile down to the CLR and get really performance runtime. But I don't think, we have other languages, there's implementations of Python and Ruby on .NET, and Python and Ruby, which both are in the dynamic category, and I think they're able to be quite effective and quite performant languages on the CLR. But I think F# really sat in this particular spot of being a statically typed language, and gets many of the benefits from that, the really strong guarantees from the type system that you get from being a statically typed language.
Yeah. You mentioned before that F# is also object-oriented, so it's another one of those attempts, although I don't mean to say that it fails, one of those languages that tries to merge functional and OO. So if you, primarily advocate functional style with a non-mutable state, how does this go together with object orientation? How do these two philosophies fit together in one language?
Yeah, I think one of the things that we've seen in practice when in F#, but also in some of the other languages like Scala, which merges these two ideas quite successfully, that really they aren't in opposition. They're really sort of in some sense sort of orthogonal design ideas. Functional programming techniques tend to be about sort of programming in the small. They tend to really benefit when you're talking about sort of the kind of things that would sit inside a method body, to do abstraction and parallelism and things. But still, the OO techniques can be used as the packaging constructs, as the way that you pull together components and expose those off to consumers, and really scale your applications up to programming into large kind of domains. Yeah. So really, we see in F# not too much conflict between those ideas. They tend to actually work quite well together in practice. The functional techniques is the way that you really write the meat of your application, and then the OO techniques is the way that you package and constrain that code and publish it off to consumers.
Okay, is that another one of the properties you advertise for F# is scalability. Is that related to this functional in the small, OO in the large kind of approach that you just talked about?
Yeah, I think in part it's the idea that once you do get up to a certain level of scale, your OO design techniques can really kick in a language like F# that does have OO and does sit on top of a runtime environment that is designed for that sort of OO scale, like the CLR is and like Java is. And so, we've seen in applications developed in F#, but also sort of know just that ultimately you're going to scale in very, very similar ways to a way that like C# or Java might scale, because you're using the same kinds of techniques when you get to that scale that you would in those languages. You're using .NET Assembly as your packaging construct. You're using classes and OO frameworks for the way that you break down the components inside an assembly. Many of the techniques are the same. And similarly, I guess one other thing I haven't talked about is the tools. F# has sort of strong Visual Studio support. That's something that we're also working on to take that a bit further. And so really one of the key parts of being able to scale is the tools. And so since we're built into Visual Studio, we have support inside Visual Studio, we are able to give you sort of the tools that are sort of natural, the debugging tools, the project system for managing your source code that are needed when you do scale up an application.
Mm-hmm. Okay, let's talk a little bit about this explorative buzzword or concept. You mentioned a couple of times, and I also read it a couple of times in various F# publications. You talk about explorative programming and using the language in an explorative way. What does that mean?
Yeah, so it's sort of the idea that one of the great things about programming is that it can be used to just generally solve problems. And a lot of the time when people are trying to go out and solve problems using programming languages, it's not that they sit down and sort of write an application from scratch. They often have some idea, they want to experiment, they have some data that's available to them, and they want to just sort of open up an interactive console and run some commands, build up a little bit of state, try to figure out the right algorithm for solving a problem. And so this idea of being able to explore, being able to pull in some data, play around with it, write some algorithms, write some code that works with that data, and then visualize the results of what you've accomplished is really what we're sort of talking about with explorative development. And it's something that a number of the scripting languages that have been popular over the recent years have been used in large part for these kind of purposes. But also in specific domains, there have been lots of these languages like MATLAB and Mathematica have been popular tools for mathematicians.
Yep.
And there's been other sort of APL, R, many other languages in specific domains that have been very interesting for going out and exploring using the sort of the magic about programming, that it can be a great tool for just solving problems. And so with F#, we're really trying to take .NET and give it a tool that's sort of strongly typed, can scale, but is also available at the sort of explorative end of the spectrum for just kind of playing around with code.
So I guess you then also have a console and an interpreter where you can just execute statements and function calls and definitions like interactively, as you just said.
Yeah, so there's an interactive, there's F# interactive,
right.
which you can use to just, you can open that up and type in any F# expressions or define F# types or create F# functions. And you can just type those in just like you would inside an F# application and execute them. And that's really, we also have some support for that inside Visual Studio to make that kind of experience pretty easy to work with.
Cool.
And so that's really, in practice, what we're talking about is having an F# interactive.
Right, okay. You mentioned OCaml before. Can you talk a little bit about the other languages from which F# is inspired? Maybe look at some of the specific features and then maybe talk about where it inherited them from?
So, so OCaml is where the sort of core of the language and certainly the kind of syntax and feel of the language comes in large part from OCaml, I think. And so it's obviously things like the let keyword being very fundamental in the language comes from OCaml. Mm-hmm. The strong static type inference comes from OCaml. I think the .NET integration comes very strongly from languages like C# and Visual Basic. Mm-hmm. And so a lot of the way in which OO is done in the language comes from C#. Right. But with ideas from many other languages which have successfully sort of looked at functional plus OO, so languages like Scala, which have done that. I think there's a lot of similarities in the approaches. Yeah,
and we'll talk about that later.
Yeah. Okay. Great. And then I think there's also a few features that kind of come from languages like Haskell. So some of the kind of monadic features in Haskell show up in a few ways inside F# with ways of doing sequence comprehensions and doing asynchronous workflows.
Yeah, we talked to Simon Peyton Jones recently, and he talked about being just down the hallway from you guys and trying to make you do the right thing. Yeah.
So he works just down the hallway from Don Syme, who was the original researcher working on F# and the sort of architect for F#. Mm-hmm. And so I think they probably have some interesting spirited discussions about the various merits of Haskell and F#. But I think there's a lot of productive sharing of ideas, and I think Haskell is a big influence on a lot of functional programming languages and definitely on F#.
Yeah. So of course this raises the question. I have to ask it: why another functional language? Aren't there enough, or weren't there enough on the .NET platform? So what was the reason to do another language?
Yes, I guess there have been a number of functional languages, but really, in some sense, none of them have really I won't say none of them, but there hasn't been really the sort of mainstream functional language yet. There's been very strong mainstream procedural, imperative languages, OO languages, but really functional languages haven't sort of broken across that barrier to being really fully in the mainstream. Though ideas from functional languages certainly have. They've moved into C#, as I mentioned. I guess they're looking at them for Java. There's plenty of ideas that are sort of making their way through, but I think F# is trying to build like a strong functional language for the .NET platform, and there hasn't been one yet that's really been able to sort of live at scale that a sort of mainstream language would need to.
And is that because nobody cared to build something like that, or wasn't there enough marketing, or is it maybe that functional languages generally haven't made it into the mainstream because people don't like, the mainstream people don't like to think in recursion and stuff?
Yeah, I think it's a combination of, I think historically there have probably been a number of reasons. I think, there have been perception issues about functional languages. There have been real issues about performance in the past has been an issue, but that's much less so now. And I think looking forward, there's just a recognition, as we talked about early on, that some of the reasons why functional programming is an important technique, that's independent of whether the language is classified, I think, as being a functional language. Really functional programming is a set of techniques, I think. And those techniques are becoming more and more valued as we sort of move towards many core and distributed programming, and want additional tools for really writing higher level kind of code even inside the method body. Mm-hmm. So I think there's sort of an increasing interest in these functional programming techniques. I think we're seeing those ideas move into the mainstream OO and imperative languages, but we're also seeing a need for sort of practical but strongly functional languages to live sort of on their own on these major platforms. And so I think that's why there's been a lot of interest in languages like F# and interest in Scala.
Okay, so one reason why we're talking about this stuff is because you're doing a tutorial at Uppsala. So why don't you tell us a little bit what the tutorial contents will be? What should people expect? What kind of knowledge do they have to bring to the table? What do they need to know before they can actually successfully understand what you're going to talk about?
Sure, yeah. So the tutorial will be pretty much an introduction that sort of starts from no knowledge of F#, and really sort of introduces a lot of the core concepts of F#. Goes through some of the things I've talked about today, but in a lot more detail and a lot more sort of hands-on look at all of this in an actual seeing what the code looks like, seeing what all the language features are, what kind of things you can do with the language. Yeah. But in terms of what kind of things we'll sort of assume folks know in the tutorial, I think a basic knowledge of the sort of .NET environment, or if you have a knowledge of the Java environment, that's probably enough to sort of talk about F#. But we won't assume too much, though we will cover ideas in a number of different domains, and folks who have a lot of knowledge in OO and functional and in other areas, we'll probably see some things they're familiar with as we talk through those.
And they don't need to understand functional programming as a precondition to the tutorial.
Oh no, definitely not. We'll cover lots of functional programming ideas in there. But if you are someone who's got a lot of familiarity with functional programming, this should be an interesting tutorial just to apply how that's applied in sort of a real world kind of a language that's being used for sort of some real situations.
Right. Okay, then Luke, thank you very much for being on the show. Thanks for downloading and listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example by clicking on the Dig, Reddit, Delicious and /dot buttons. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.